So let's take what we just came up with and let's use some notation to make things clearer. Let's introduce a capital P super K. That is the matrix that has the first k plus 1 search directions in it. Now notice that when we are in a typical iteration, these are the previous search directions. This is actually the search direction we're trying to determine what kind of property it should have. And together, it is a linear combination of those search directions that's going to give us our next approximation for where the solution is. Okay? So with that, we can take our expression right here and just put it there again. And what we then notice is that, hey, instead of thinking of the span of all of these vectors, let's make those vectors into the columns of a matrix, and then talking about all linear combinations of those columns is the same as saying take vectors y of the appropriate size and look at all products of matrix pk with those vectors y. So this describes this same set. And then we can do our usual thing. Let's take our vector y and let's partition it into a top part and then the last element in the vector. And let's take our matrix pk and let's partition it into the matrix of all previous directions and the current direction. And let's see what shakes out. Well, actually, you're going to see what shakes out. You're going to verify in the next homework that what we have here gives us this expression right here.